Thank you. So hi, I'm a Python core developer, and I'm one of the authors of PEP 765, which was approved by the Steering Council for Python 3.14. And it's a simple PEP, but it has quite a lot of a story behind it. So I thought I would tell that story, and through this you will get a bit of insight into the PEP process and how decisions are made in the Python core team, and about changes to the language, and kind of how the sausage is made. So the context here is the finally block, which we attach to a try statement. So in Python, we handle exceptions with try except. In the try block, we do some code that we hope it will succeed. If it raises an exception, we go to the exception handler and we handle the exception. And we can also attach a finally block that executes no matter what happens. So whether we fall through and continue executing this function, or we return from the try block, or we raise an exception from a try block, or we raise an exception from the try block and from the except block, whatever happens, this cleanup will execute before we leave this function, or after we finish executing the try except. So, and the intention is that this will be cleanup. So what is cleanup? You open the file, you try to do something with the file, maybe it succeeded, maybe it didn't, you handled any exceptions that happened. At the end, you close the file no matter what. So you don't want to leave the file open no matter what. But it gets interesting when you start doing things like raising exceptions in a finally block. So imagine this code. You raise an exception from the try block, then you get to the finally block. You're supposed to propagate this exception to the caller, but now in the finally block, we raise another exception. Okay, so what happens now? So what Python will do is it will chain the exceptions through the context field of the exception in the finally, and then the traceback has both exceptions as chained. So there was a value error, and while we were handling it, there was a type error. So all the information in all the errors that occurred is there. So that's good. It might be confusing that we changed the type of the exception that is raised, and the original exception is only in the context. There can be edge cases where this can cause problems, but I think this is the best we can do, because we can't say don't raise exceptions from the finally block. There's no such thing. Any code can raise exceptions. And any code, a keyboard interrupt can happen if the user does Control-C. Any code can raise exceptions. So given that, I think this is the best we can do. Now, if we do return from the try block and then return from the finally block, then the return from the finally block wins, right? We executed a return, we're about to return, but we say, wait a minute, we have a finally block, we need to run that before we return, and then the finally says, return something else. So the finally overwrites the return value from the try block. Now, that's, we don't have a notion of chaining return values, there's only one return value, so that's kind of the only thing we can do, but that's weird enough that you might get this in kind of gotcha pub quizzes or job interviews. So it's a bit strange. But when we have this combination, we raise an exception from the try block, and then we return from the finally, then it gets really bad, because what happens now is that the return from the finally swallowed an exception that was raised from the try block. So this function will return finally, and you will never know that an exception was ever raised. So this is bad, and it's pretty much consensus that this is a bad situation. The reason it's bad is because we have in the Zen of Python this principle. If you do import this in a Python prompt, you will get the Zen of Python. One of the items is that errors should never pass silently unless explicitly silenced. And in this try except, we call the function, it does something. It might raise an exception, because any code can raise an exception. And then we return something in the finally, and there was no exception handler. It's just try finally. There's no exception handler in this program, and an exception got swallowed. So that is not explicit. And this should not happen according to the Zen of Python. but it does happen. So up until Python 3.13, we had a situation where Python has this problem, but linters warn us about it. So all the linters had warnings about this, and basically treating it like a coding style issue. So this is kind of a linter warning level thing. PEP 765 that I co-authored with Alisa Coughlin, this raises it to a level of, this is a harmful feature, we want to remove it from the language. We want to say this is not a part of the Python language, it's that bad. And the PEP says CPython will emit a syntax warning, but other Python implementations may emit a syntax error. The reason for this is that we think it should be a syntax error, because it's not a part of the language, but we have 30 plus years of backwards compatibility to worry about, so we kind of made a concession and said it's a warning, let's make it a bit softer. And so PEP 765 was accepted. This was actually proposed in the past. In 2019, there was PEP 601. It said, let's raise a syntax error for return, break, or continue that exit a finally block. And that was rejected by Guido. This was just before the Steering Council started deciding about PEP, so it was still Guido. And his rejection note lists the reasons. One thing he said was, look, other languages do exactly this. They have the feature and the linters warn about it. So kind of everybody does it, that's how it is. And he also said, I can imagine situations where this feature might be useful. For instance, if the return in the finally is conditional. So it's not overriding the return value from the try block, but it says under certain circumstances I want to change the return value. So then it's not as silly as the example I showed you a few slides ago. So basically, he was saying, yeah, maybe there's a problem here. We don't really know how big the problem is. So we don't know what the benefit of this change is. We have no idea what the cost of it is because we don't know how useful this feature really is. Maybe it is useful. So the cost-benefit of the change was unclear. It was, let's just not change anything. And what changed for PEP 765 is that last year I did an empirical analysis of the situation. So what I did was I downloaded the few thousands of 8,000 most downloaded PyPy packages, got the source code. These are scripts that I already had lying around from Guido and from Hugo, who's here. So got the source code for all of this open source code, and kind of ran an AST analysis, a static analysis on all this code, and looked for whether we have a return, break, or continue that would exit a finally block. So we're looking for finally that has a return in it, but that return is not in a function that is nested in the finally. So the return exits the finally, which is inside a function. And similarly, a break or continue, but break or continue that is not inside the loop that is inside the finally. So it actually exits the finally block. So this thing ran, and the results were, it analyzed 120 million lines of code, and it found 203 instances of this. So about 2 per million lines, yeah. Most of them were returned, the vast majority. There were a handful of break and no continue. So mostly return. And it broke up like this. So 46 of them were in unit tests. And these are unit tests for things like linters. So if a linter has a warning for this, then there will be a test. And the test will have this code pattern as an input. So it found those. We can ignore them, because that's not real code. These tests exist only because the feature exists. It's not like someone needed the feature. 8 instances are possibly correct. It looked like maybe there was a comment saying, let's swallow all the exceptions here, or maybe there was a try except that kind of caught all the exceptions and tried to kind of guarantee that there's no exception. So 8, when I looked at them, I thought it's possible that they're doing what they intended to do. 149 appear to be incorrect from my reading. If I look at it as a code reviewer, I would flag that as problem code. And 2 patterns that repeated many times were, the first one at the top is when you have a return that does nothing, but it's because it's immediately overwritten by another return. So in this return, if an exception happened, return not implemented, and then finally return something else. So return not implemented will never happen. So I don't know what the author intended, but it doesn't look like they intended to write a line of code that does nothing. So my assumption is that there's something wrong here, that this code is not doing what the author intended. The second example, and this was even more common, was something like this. You have a try block, then accept exception, log the exception, and then return some value. So now, if there was an exception, which is a subclass of exception, then we log it, and we return some value. If there was an exception raised that is a base exception, like keyboard interrupt, memory or error, or some user-defined base exception, these are not subclasses of exception. And these are considered the more serious exceptions that we don't want to ignore. We don't want to do a catch-all that swallows them. In that case, the exception will be swallowed and there will be no trace in the log. Now, again, I find it hard to believe that someone did that deliberately, to say that the really serious exceptions we will just swallow silently, and every other exception will be log and then swallow. I think the intention here was to log and swallow everything. Now, so overwhelmingly we see that the feature is used incorrectly, mostly. The second stage of this analysis, I contacted the maintainers. So we had 149 incorrect usages of things that look incorrect in 73 different projects. I created an issue in the bug tracker of each of these projects and waited 2 weeks. And then within 2 weeks, I got 40 responses. 35 acknowledged, said, yep, I get it, there's a problem, we'll fix it. 15 already had PRs to fix it within 2 weeks. 3 replied, okay, this code is not maintained, we're not going to do anything. 2 said it works as intended, one of them I believe. Maybe. One issue was linked to a pre-existing issue that they had about Control-C being ignored. They didn't know why, but they had an open bug about that. So they said, oh, that might explain that. And 2 were labeled as good first issue. So they considered it easy, an easy fix. And I also consider it easy to fix. I didn't see any cases where I thought there's like some major complicated rewrite here. It's often just take the return out of the finally and put it after the end of the try except, or something not much more complicated than that. So the conclusion was this feature is not used that much, about 2 instances per million line of code. Maybe that's because the linters have been warning about it. So people often probably ran the linter and got rid of the problem. When they're used, the vast majority of the times, they're used incorrectly. And maintainers tended to respond positively. That's an indication of how disruptive this might be, how much pushback we might get from the community. So this analysis showed us that the benefit is high. We will flag many possible bugs. The cost is fairly low. We don't have these kind of fancy use cases that Guido conjectured might exist, where people do a conditional return. I didn't see that. I didn't see places where this feature is really necessary. And we also reduced the cost by making it a warning rather than an error. So the cost benefit became, first of all, clearer. We actually quantified in some way the cost and benefits, and we reduced it. We reduced the cost. But this didn't go smoothly. It's not like, it's never quick, right? It's not like you got, I mean, so the reactions were very mixed. Like, some people saw this analysis and said, oh yeah, we got to get rid of this. This is so bad. This is worse than I thought. This is obviously, get rid of it. And then there were the people, don't touch it, don't break it, don't, and this is normal. Every PEP that anyone suggests, there will always be a cost, and there will always be a discussion of whether the change is worth the cost. That is completely normal. Usually, the discussion ends once the steering council makes a decision about the PEP. So if it's accepted, people move on to argue about the next PEP, and if it's rejected, there's nothing to argue about. In this case, it kicked off again a few weeks ago. Somebody ran their CI with warnings as errors, with where an imported package that they don't maintain had this, so they couldn't fix it in the code. And their configuration was to not pre-compile anything, so they would compile everything whenever the tests were running. And then the whole discussion flared up again. We broke someone, so now let's revert it. Maybe someone will make a PEP to revert it for 3.14.1. We'll see. It goes on. I did comment, I mean, it's out of my hands. If someone makes a PEP and the steering council accepts, that's what will happen. I did comment that effectively deprecates our warning system. Because if a warning is as severe as an error, because people run with warnings as errors, then we might as well not use the warning system. Okay, I'm exaggerating because the issue here was that there's a limitation in the warning filters that impact syntax warnings. Some warnings are easier to filter out. So it's not all the warnings, but maybe syntax warnings for compile time issues. We don't have a warning system for if warnings are errors. There was an article in LWN in December last year summarizing the discussion as of that date and the controversy and so on, and with a great title, Finally Continuing the Discussion over Continue and Finally. That was good. Now, I spoke about this issue of the cost-benefit. That was most of the discussion. There was another argument that came out. This actually, Guido brought this up. He said, I see the problem in the analysis. It's obviously, there's a problem here. We need to do something. But he said, it makes me sad that language features don't just compose orthogonally. You should be able to nest a try block in a function, in a for loop, in a with statement, not think about the context and just use any language feature wherever you want. I share the sentiment, but I reminded him that in a PEP that we wrote together a few years ago, the exception groups and accept stars PEP, there was a situation where we said in the accept star block, we're not allowing return, break, and continue because they don't make sense in that context. So there is a precedent for this. And this was also, the steering council actually mentioned this as a factor in their decision to accept PEP 765, the fact that we have a precedent for saying there are places where return, break, and continue don't make sense. Now, I wondered about this issue of other languages Like other languages have this problem. Did they do the kind of analysis I did? What do they know about this? I didn't find anyone who did some kind of analysis of the empirical code to see how often it's used correctly or incorrectly. This I didn't see. But I did find a 2006 entry in a Java security vulnerability database that lists this as something that a security audit should flag. And also from the Java world, a blog from 2011 where, don't do return and finally because look what happened to me. And this is a description of a real-world bug where login failed and raised a login exception, and then a return and finally swallowed the exception, and then the program continued assuming that it had logged in, and it hadn't. So bad things happened. Then there's PVS Studio is Java linter. They listed this as an Apache Hive bug as one of the top 10 bugs that they found in Java projects in 2019, I guess by static analysis. So we see that this has been known for quite a while. I looked up, as far as I can tell, I tried to look up in other languages what goes on. So Java, JavaScript, Scala, Groovy, Ruby, and Kotlin all have the same issue with return and finally, as far as I can tell. But already in 2002, C# blocked it, return, break, and continue our compilation error in a finally block, and finally is just for cleanup. And then Go and Swift and Rust have completely different solutions. They don't have finally block. They have different approaches to clean up. And I also wanted to put this in the perspective of lessons learned about programming language features and programming paradigms over the years. So there are a number of, we keep learning about what works, what doesn't work, and I think this issue of return and finally is just one of those lessons. Other languages already moved on. Python is trying to move on. You might get a syntax warning in Python 3.14 if they won't revert it. Thank you.
This on? Right. Thank you very much, Irit. That was extremely interesting. I think we probably have time for maybe one question, if there's one question. Yeah. Save me running up the stairs.
So you were willing to allow that occasionally it might make sense to allow this? Occasionally, rarely. You said there were 8 people that got it correct. So assuming I'm some sort of galaxy brain and I know what I'm doing, is there a way for me to write this in such a way that I can suppress the syntax warning so that it can be in code and nobody complains?
Absolutely, I think they put a man on the moon with GoTo.
Oh, thank you again, Irit. I imagine that you'd be very happy to continue this conversation with people in the hallways and so on. Can I ask, was Larry one of the culprits? Definitely opened my eyes to some issues. Our next talk in this space